Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.19. While solving this problem, we will be using Kirchoff's voltage law. According to this law, sum of all supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.19. Find the value of voltage V0 in given below figure using mesh analysis technique. This is the circuit diagram of given problem. Inside this network, we have to find voltage across this 2 kilo ohm resistance labeled as V0. While we have to adopt mesh analysis topology to solve this problem. We know that in order to do mesh analysis of any network, we have to follow some steps. The first step is to find out the maximum number of meshes that can be formed in a network. So we will use this equation to find out the maximum number of meshes that can be formed in this network. So in our case, the number of branches is 5 and number of nodes are 4. So 5 minus 4 plus 1 will be equal to 2. So maximum 2 number of meshes can be formed in this network. In second step, we have to assume currents along with their polarities inside these meshes. So I am assuming current I1 is flowing in clockwise direction in first mesh and current Ix is flowing in clockwise direction in second mesh. According to the directions of these currents, polarity notation across resistive elements is marked. Now we will apply Kirchoff's voltage law inside this first mesh. We will start writing KVL equation from this 4 kilo ohm resistance. Current entering terminal is positive, so voltage across this 4 kilo ohm resistance will be taken with positive sign. Next, current entering terminal is negative, so voltage across this dependent voltage source will be taken with negative sign, minus VDS. Next, current entering terminal is positive, so voltage across this 2 kilo ohm resistance will be taken with positive sign. Now we have to replace these voltage with their equations. Voltage across this 4 kilo ohm resistance will be equal to the product of current through it and the value of resistance. In this case, this is the common branch between these two meshes. So, two currents will be flowing from this branch and both are in opposite direction to each other. Now we are taking voltage across this 4 kilo ohm resistance according to the direction of current I1. So we will consider current I1 is higher than current Ix. So the resultant current that will be flowing through this 4 kilo ohm resistance will be equal to I1 minus Ix. This subtraction is performed because both currents are opposite in direction to each other. So voltage across this 4 kilo ohm resistance will be equal to the difference of these two currents multiply the value of resistance 4 kilo ohm. Next, current entering terminal is negative. That's why we have taken these voltage that are depending upon the value of Ix. These voltage are taken with negative sign, minus 2000 times Ix. Next, voltage across this 2 kilo ohm resistance will be equal to the product of I1 and 2 kilo ohm. Now open these brackets and solve this equation. Product of 4 kilo ohm and I1 will become 4k I1. Similarly, 4 kilo ohm will multiply with minus Ix. It will become minus 4k Ix. Minus 2000 Ix plus 2k I1. Now add values having same variables together. 2k I1 and 4k I1 will become 6k I1. Similarly, minus 2k Ix and minus 4k Ix will become minus 6k Ix. Now we cannot further solve this equation, so we will label this equation as equation A and move towards next mesh. Now start writing KVL equation for this second mesh. Start from here. Current entering terminal is negative, so voltage across this voltage source will be taken with negative sign, minus 12 volt, plus voltage across this 2 kilo ohm resistance will be taken with positive sign because current entering terminal is positive. Similarly, voltage across this 4 kilo ohm resistance will be taken with positive sign because current is entering from positive terminal. Now replace V0 and V4 kilo ohm with their respective equations. V0 is equal to the product of current Ix and 2 kilo ohm. Voltage across this 4 kilo ohm resistance will be equal to the product of current through it and the value of resistance. In this case, we are taking voltage across this 4 kilo ohm resistance according to the polarity of current Ix. So we will consider current Ix is larger than current I1. That's why we have subtracted I1 from Ix. So the difference of these two currents will be flowing from this 4 kilo ohm resistance in upward direction. Now open these brackets. 4 kilo ohm will multiply with Ix, it will become 4k Ix, and 4 kilo ohm will multiply with minus I1, it will become minus 4k I1. Place this minus 12 on the other hand side of equal to separate it from variables and add values that have same variables together. The equation will become minus 4k I1 plus 6k Ix equal to 12. We cannot further solve this equation, so label it as equation B. Up to this point we have two equations. The equation A is retrieved from this first mesh and equation B is retrieved from this second mesh. Now we will solve these two equations to find out the value of current Ix. We are interested to calculate the value of current Ix because voltage across this 2 kilo ohm resistance is the product of current Ix and 2 kilo ohm, and it is asked in this scenario to calculate the value of voltage across this 2 kilo ohm resistance. So first of all we will try to find out the value of current Ix. For that purpose we will multiply equation A with 4. The equation will become 24k I1 minus 24k Ix is equal to 0, and equation B will be multiplied with 6. So equation will become minus 24k I1 plus 36k Ix is equal to 72. Now add these two equations together. Minus 24k I1 and plus 24k I1 will cancel out with each other. 36k Ix minus 24k Ix will become 12k Ix. And on the other hand side of equal, only 72 will left. Now in order to calculate the value of current Ix, divide on both sides with 12k. The value of current Ix will become 6 milliampere. After calculating the value of current Ix, we are able to calculate voltage across these 2 kilo ohm resistance that are labeled as V0. So V0 is equal to the product of current Ix and 2 kilo ohm. Replace Ix with its value, that is 6 milliampere, and take the product of 6 milliampere and 2 kilo ohm. So the value of V0 will become 12 volt. This was Chapter 3 Learning Assessment E3.19. Thank you. See you again in next video.